Wouldn't it be cool if you could plug a USB into a computer and in less than 15 seconds it sends a connection to your attacker machine and provides full remote access? Well, that's exactly what we are doing in this video, and I promise it's gonna be fun and easy to do. So if you have ever wondered how dangerous a USB flash drive or charging cable found on the ground is and what it can really do, well, it is a lot. I can't wait to show you, so let's get straight to the point. We'll be using this AT-Tiny85 Arduino compatible microcontroller. You can get one of these for less than $5 a piece. There is a link in the description. Now, in order to program this chip, we need to install the Arduino IDE. That is as simple as opening a browser and typing in Arduino IDE, opening the first link, select your OS and hit download. And here we will follow a standard installation process. While we do this, let me give you some context. We can make this microcontroller look like a flash drive, a charging cable, a headphone jack dongle, or any other USB device you can think of. But what it would really act like is a keyboard. This device is going to send keystrokes to the computer when plugged in, and that is how we are going to control the target computer. Okay, if you've reached this point, Arduino IDE has been successfully installed on your system. We're gonna do a few more setup steps. So you're gonna go to File, Preferences, and here in Additional Board Manager URLs, you're going to paste this link that I will have in the description. You're gonna click OK. Now you're gonna go to Tools, Board Manager, and search for Digistump AVR boards, this one, and hit install. Hit yes on everything that pops up. Now go to Tools, Board, hover over these Digistump AVR boards and select this one. To test that everything works correctly, we are going to add this include, add these 3 lines of code in the setup function, and send this keystroke. Now, let me explain. If you've never worked with Arduino before, basically we have a setup function and a loop function. This function executes once when we plug the USB, and this one executes continuously after this function has executed. And what I'm doing right now is I'm setting up this DigiKeyboard class, which we can use to send keystrokes like this. And what this here is the R button and the Windows button. So it is basically Windows R, which would open the run box if this successfully executes. So let's do a test. I'm going to hit this button here. And as you can see, it says uploading plug-in device now. So I'm going to plug in the USB. Once I plug it in, this code is going to get uploaded to the USB. And the next time it is plugged in anywhere, it is going to execute that. And as you see, the test was successful. How do we know that? Well, once it says micronucleus done, thank you, this means it was uploaded successfully, and we saw our run box pop up. It popped up because of this line here. I'm going to plug out the USB, and now we need to figure out how we are going to set up a reverse shell in this function here. If you don't know what a reverse shell is, you might want to check out this video. Okay, so now I'm on the attacker machine, Kali Linux. What we need to do now is set up a few PowerShell scripts that the USB is going to download and execute. Let me explain this more clearly. The USB is going to act like a dropper. A dropper is a small piece of software that downloads a bigger piece of malicious software and executes it. You might ask, why are we setting up the USB as a dropper? I will explain that in just a moment. But now let's set up our scripts. I'll open up VS Code. The first script we're going to have is simply a PowerShell reverse shell. Let's just find one online. While I'm doing that, I want to remind you that this video is for educational purposes only. Please do not misuse the information provided. We are also going to prepare 2 more scripts. Now, I will demonstrate this later, but in short, what this script is going to do is it is going to allow us to completely hide the reverse shell window from the user. And also we are going to need a script to disable the hidden terminal. Don't worry, this will make sense in a moment. I will save both of these, I will close this, and I will host these files on an HTTP server. Oh, and one thing I forgot is to change the IP and port of the reverse shell. Again, if you don't know what I'm doing, check out this video. Now I have our development machine and our attacker machine side by side. Now all we really gotta do with the USB is run a PowerShell command that looks like this. What this is going to do is it is going to pull this reverse shell payload that we have, and it is going to execute it without saving it as a file. So it would execute it in memory. Let me show you. If we have a listener running on the attacker machine and we run this, it is going to pull the reverse shell and it's going to execute it, and we have our shell right here. But there are a few problems. First, we need the USB to do that instead of us. And second, as you can see, even though we set window style hidden, which is what this means here, this black window didn't completely hide, but instead it minimized. And that is what all these other scripts are about. We're going to change some system settings which will allow us to completely hide this window, so the user doesn't see a black window and wouldn't be able to just close it and terminate the reverse shell. So let me show you. If we run this command, which is going to pull the enable hidden terminal script and execute it, and if we were now to open a new command prompt and run this one, and also have a listener running, as you can see, it gets completely hidden. It doesn't just minimize, and we still have our access here. So that's the point of the whole thing. And we can use the disable script to revert these changes so that the user doesn't have any clue about a potential compromise. Oh, and also let me explain one more time, just so it is clear for you guys. This command here is the dropper that I talked about earlier. It runs PowerShell, and it runs the invoke expression cmdlet, which is used to run PowerShell scripts. And what we run is actually this thing, and this thing is the invoke web request cmdlet, which invokes a web request and pulls down this script. So really what we do is we pull this script from here, it is hosted right here, we pull it and we execute it. That's all that means. And why we do it with a dropper instead of just running the script using the USB, I'm going to explain in just a moment. But if we run this, you can see it gets pulled and the setting is now configured back to normal. So if you open a command prompt and we do PowerShell -w hidden, as you can see, it gets minimized again. Okay, I hope that is clear. If not, feel free to ask in the comments or join the Heptasec Discord community and ask there. I will be sure to answer. Okay, once we have all this info, let's now set up the USB to do this all by itself, so the user has to do absolutely nothing. So at this stage we already have Windows plus R pressed, so we have the run button up. What we need to do now is send keystrokes to type in cmd, and that's how we do it. We use the printline function. The printline function simply types text. So if you had to do manually what this is going to do automatically, it would be pressing Windows plus R and typing in cmd like this, and also hitting enter, because printline adds a new line character at the end. So it would also hit enter, and currently we will be in this stage here. That's going to be done automatically. So once we are here, we can simply send the keystrokes for the command that I showed you earlier. This is the command that will enable the hidden terminal. And also an important thing we need to do is add some delay between every command, like this. The reason we do this is so that the target machine has time to load the window before we start typing into it. If it's too fast for you, you can increase the time, for example, to 3 seconds. But anyway, once we have executed this PowerShell command, we can also exit. So this would open this window, run this command, so PowerShell and etc, etc. It's going to run it, and then it's going to type in exit and hit enter. That's going to be done by the USB automatically. So that's just our way to enable this hidden terminal feature using only keystrokes, because as I said earlier, this USB is simply kind of like a software keyboard. It is able to send keystrokes. So the next thing we want to do is open a new command prompt window and execute the reverse shell. We'll do this like so. What we have here is pretty much we send the keystroke for Windows plus R again, and we type in cmd. And now here we just pull the reverse shell payload and of course execute it, because printline sends a new line character, which means this line is going to get executed. Let's add a delay after this as well. And the last thing we need to do is disable the hidden terminal feature. That's gonna be done like so. Again, we hit Windows button plus R, we type in CMD, and this time we execute the disable hidden terminal script. And then we exit the window, just like we did with the one that enabled the hidden terminal. With that, our malicious USB code is done. We have successfully set up 3 PowerShell dropper one-liners that are going to pull and execute 3 scripts from our attacker machine. So now let's test it. I'm going to hit Ctrl C on this one, and I'm gonna run the listener again. Let's hit this button, and I will plug in the USB. As you can see, it's going to open CMD, enable the hidden terminal, close this window, open CMD again, execute our reverse shell, completely hide the window, our reverse shell popped up, and now it's going to disable the hidden terminal. As you can see, it happened super fast and it is already done. So now we are free to pull out the USB as we already have remote control of our PC. Now, one thing I promised to explain is why we use droppers here instead of running the script straight away. And the reason is, if I scroll up here, you can see here it says Sketch uses 3292 bytes of program storage space. Maximum is 6012. Pretty much our microcontroller has a limit of how much code we can write in it. And if we were to write all those scripts on the USB, they wouldn't fit. So that is why we are using droppers, which are very small pieces of code, which will pull bigger code. Okay, so now let's do a test run. I'm going to close the Arduino IDE. We can save our sketch. I will restart this listener. And now you can imagine that this PC right here is the victim PC. This is the computer of someone who found a random USB cable and decided to plug it in their computer. And this side right here is the screen that the attacker sees. I'm going to plug in the device now. And that's it. That's how fast the attack happens. Now here we have full control of the remote computer. We can go to the desktop and send a message to our victim to let them know that we are now in control of their computer. And the file popped up right here, and there it is. Now, one thing to note is that the victim machine had antivirus disabled the entire time. If you want to know how you can do this whole thing with antivirus enabled on the target machine, I would suggest checking out my antivirus evasion video. Okay, let's wrap up by covering defense against this. Well, it's pretty simple. Never plug in unknown USBs into your PC. I think this video was a more than sufficient example of the danger. In any case, thank you very much for watching and see you next time.